Jupiter, the largest planet in our solar system, is a gas giant with the remarkable ability to absorb and compress millions of tons of space debris. So why haven't we considered using it to tackle one of Earth's most pressing issues, our trash problem? What if we were to transport all of our garbage into space and deposit it into Jupiter's atmosphere? How would we even manage such a monumental task, and would it alleviate our environmental woes or exacerbate them? This is the scenario we explore in this what-if scenario. Before delving into the logistics of launching rockets filled with various forms of waste toward Jupiter, let's first examine the current journey our trash undergoes from creation to disposal. Waste management is a multifaceted process worldwide, encompassing a range of strategies from curbside bin pickups to advanced recycling programs. After disposal, trash typically finds its way to landfills or incinerators, depending on regional infrastructure. However, not all waste reaches these designated facilities, as human litter can be found virtually anywhere humans inhabit, including remote areas like the Pacific Ocean, evident in phenomena like the Great Pacific Garbage Patch. As landfills overflow and sea levels rise, humanity grapples with the urgent need for a sustainable solution. Perhaps the solution lies over 778 million kilometers away, in the form of Jupiter. Back to the task at hand, transporting Earth's trash to Jupiter. Such an endeavor would necessitate groundbreaking technological advancements and international collaboration on an unprecedented scale. From waste collection to processing and transportation, every step of the process would require innovative solutions. Automated drones would play a crucial role in waste collection and processing, ensuring that the garbage is compacted and decontaminated before being loaded onto spacecraft bound for Jupiter. The spacecraft themselves would need to be equipped with advanced propulsion systems capable of traversing the vast distances between Earth and Jupiter repeatedly. Nuclear fusion or ion thrusters might offer the necessary propulsion power, although such technologies remain speculative at present. Once the waste-laden spacecraft reached Jupiter's atmosphere, they would release their cargo into the gas giant's turbulent atmosphere. As our trash descended through Jupiter's atmosphere, it would face extreme temperatures and pressures, causing it to disintegrate into its constituent elements. Metals would melt and mix, plastics would break down into their molecular components, and organic matter would be consumed by the planet's intense forces. Ultimately, our trash would be recycled in Jupiter's depths, contributing to the planet's ongoing evolution. However, this ambitious plan raises ethical and environmental concerns. Transporting vast amounts of waste into space would require an enormous energy expenditure and could have unintended consequences for Earth's ecosystem. Additionally, relying on Jupiter as a cosmic garbage dump could perpetuate unsustainable consumption patterns and detract from efforts to reduce, reuse, and recycle waste on Earth. While the idea of dumping our trash into Jupiter presents a novel solution to Earth's waste problem, it raises complex ethical, logistical, and environmental considerations. Ultimately, addressing our trash problem requires a multifaceted approach that prioritizes sustainable waste management practices and environmental stewardship on Earth. Designing a program to transport garbage from Earth to the Jovian atmosphere would necessitate significant technological advancements and extensive international cooperation. This undertaking requires a complete reimagining of waste management practices. Initially, waste could still be disposed of in conventional bins, but thereafter, governments would need to deploy sophisticated automated drone systems to process the waste for space travel, Compactor sites capable of handling unprecedented volumes of garbage would be essential, compressing it into dense objects suitable for space transport. The scale of processing facilities must match the approximately 2.1 billion metric tons of global waste generated annually, a figure expected to rise. Equally crucial is the thorough decontamination of waste to prevent the inadvertent transportation of terrestrial microbes to Jupiter, potentially impacting alien life forms. Transporting such a massive amount of trash across the solar system to Jupiter would require spacecraft of unparalleled size and capabilities. These vessels must withstand repeated long-haul journeys between Earth and Jupiter, necessitating advanced propulsion systems like nuclear fusion or ion thrusters. While achieving this feat would represent a monumental leap in space exploration technology, caution is warranted before proceeding. Upon reaching Jupiter, spacecraft would release their cargo into the gas giant's atmosphere. Jupiter's immense gravitational force would ensure the trash descends deeper into its swirling, vividly colored gases, where it would undergo further disintegration and recycling. The prospect of depositing Earth's trash into Jupiter poses significant challenges and ethical considerations. While it offers a potential solution to our planet's waste crisis, it requires careful planning, technological innovation, and international cooperation. Sustainable waste management practices on Earth remain paramount. Descending into the upper layers of Jupiter's atmosphere, our waste faces freezing temperatures of approximately 45 degrees Celsius and pressures similar to those experienced at sea level on Earth. However, the conditions become even more extreme as the trash encounters clouds of ammonia gas. The protective casing of the cargo bins begins to erode, and as atmospheric pressure skyrockets to millions of times greater than Earth's sea level, the bins collapse, dispersing clouds of trash that rapidly disintegrate as their molecular bonds are torn apart. If a bin were to penetrate the deepest layers of Jupiter, it would never reach a surface, as the planet lacks a solid one. Instead, anything nearing the core would undergo a transformation into its most elemental form amidst infernal temperatures reaching up to 24,000 degrees C. Metals would liquefy and intermingle, while plastics would break down into their smallest molecules. From afar, observers would witness this disintegration, signaling the complete recycling of our trash within Jupiter's core. However, this process would necessitate a return to Earth to begin anew, embarking on a risky journey fraught with hazards, including navigating the asteroid belt. The potential for a cosmic disaster looms, envisioning a scenario where a malfunctioning trash ship explodes, scattering garbage throughout the solar system for eternity. Contemplating the possibility of eliminating trash by transporting it across space raises ethical considerations. Would this newfound solution encourage complacency in waste reduction efforts on Earth, leading to increased production of trash? Before delving into such a monumental undertaking, it is imperative to reassess our treatment of the planet and acknowledge the environmental impact of developing colossal spacecraft and consuming vast amounts of fuel. Rather than pursuing such ambitious projects, redirecting efforts towards reducing consumption, improving recycling systems, and fostering sustainability partnerships with governments and corporations would yield more tangible benefits. Perhaps alternative disposal methods closer to home, such as utilizing volcanoes, warrant exploration. However, that is a tale for another scenario. It's essential to reflect on our environmental responsibilities and consider the broader implications of our actions. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.